All right, we're going to go ahead and get started. So welcome to our session, Optimize Your Data Center with Microsoft Services. So my name is David Zimbicki. I'm a solution architect in Microsoft Services. My focus is virtualization, private cloud, infrastructure as a service. And then with me I have Adam Fazio.
Hello, thanks for coming on a Wednesday at 4:30. My name's Adam Fazio. I'm also a solution architect. I work in our team called the Data Center and Private Cloud Center of Excellence. And Dave and I have been working together on these solution offerings and also on the Microsoft Private Cloud Fast Track program for a few years now.
So since we have everyone on this side, I'm going to sort of focus on the audience there. So there's a couple of objectives to the session. We're going to talk about who is Microsoft Services and what is the Data Center Services portfolio. So we'll go through that relatively quickly for anybody who's not familiar with Microsoft Services and what we do. Then we're going to talk about what we call the infrastructure as a service product line architecture, or our reference architecture for best practices, ways to deploy Hyper-V System Center to support an infrastructure as a service scenario. So we'll talk about why we have a standard reference architecture, what a fabric and fabric management architecture is, and then some of the deployment scenarios for that architecture. The reason this is important to you is because in the near future, we'll talk about it at the end, within a couple of weeks, we're going to be publishing a lot of this content onto TechNet so that you guys will have access to these materials, access to some of these best practices that we talk about here, and then in cases where you need additional assistance and so forth with design or implementation, that's what our group does. So basically, we're going to talk about who is the Microsoft Services and what is the portfolio. So for those of you that you don't know, Microsoft Services is a fairly large organization. So you can see some of the stats up there, 17,000 employees, many different countries and so forth. That number includes our product support services, okay? So, these are the people that answer the phone when you call Microsoft with an issue. These are people like Adam and myself that go out to you as customers and help you do architecture, design, and deployment engagements, as well as our strategy and support organizations. So Microsoft Services is a relatively large organization, but we're one part of, obviously the much larger partner ecosystem that deals with all of the different areas of technology. Within the Microsoft Services, we have people and groups that focus on the data center and focus on virtualization and private cloud. So one of those groups is the Worldwide Data Center of Excellence inside of Microsoft. Some of these folks are dedicated 100% to this space. We also have a community of architects and consultants who are very deep on the different products and technologies that comprise private cloud. Okay, so in cases where customers want to have assistance in the areas that we're going to talk about, many times it will come out of this group of people. We've got some of the guys from that team in the back. Adam and I work on that team and work with that team all the time. So what we wanted to sort of just point out at the top of the session here is that inside of Microsoft Services, there's a lot of dedicated people that work in this space, and these teams are growing rapidly as Hyper-V and System Center are growing rapidly in terms of deployment. Okay, so the current architecture landscape is one of the reasons that drove our development of some of these reference architectures. What we find both internally with our partners and with customers is there's what we call islands of best practice. Okay, there may be some customers or some parts of partners that are great at designing Hyper-V clusters. There may be other areas that are great at doing System Center Operations Manager deployments and so forth. But what we started to see was that across customers, partners, and even inside of Microsoft, there wasn't sort of a best practices all-up design for all of Hyper-V, all of System Center together to deliver an infrastructure as a service scenario. And so that really drove some of our internal thinking and said, okay, we need to solve this problem because customers are spending a lot of time sort of reinventing the wheel, trying to figure out what's the best way to deploy some of these technologies. So what we do inside of services is we have a portfolio of solutions and offerings, okay? And so what that includes is things like packaged services where we'll have engagements to come help you design, a Hyper-V environment, design how you're going to deploy System Center and so forth. We have deployment frameworks, which are scenarios where we can help automate the deployment of the products so that they get implemented in your environments faster. Okay, what we don't want to do is have customers spending weeks, months, long durations of time just trying to get products installed. While you're installing, that means you're not getting any real value out of the products. So our deployment frameworks are all about automating as much of that installation experience as possible. The product line architectures, which will be the focus of this session, this is that detailed architecture guidance of what and how to deploy the Microsoft stack. And then the benefit of sort of utilizing these resources is it results in an extensible platform. So what we mean by that is if 10 customers utilize our reference architecture, then we can create automation, or our partners can create automation and extensions to those architectures that'll be usable at more than one customer. Okay, so what it helps us do is it helps us create a growing body of assets and resources that we can provide to our customers and be sure that it's going to be able to run and function as expected because they will have implemented this common reference architecture that we're talking about. For an individual enterprise who might be a consumer of this architecture, it's the same type of scenario. You would be deploying a solution that you know Microsoft services, the Microsoft product groups, and basically all of Microsoft has blessed as the recommended way of doing these implementations. Okay, so that's some of the value of these packaged services and solutions. Okay, so what does it consist of? The first step is intellectual property. Okay, so we'll talk a little bit later about how these are developed, but basically what we start out with is a set of guidance. Okay, so the top two, the fabric architecture and management architecture, they associate to Hyper-V and Windows failover clustering as the fabric, and then fabric management is System Center 2012 SP1 and so forth. With that basic architecture in place, fabric and fabric management, then that can be extended into particular scenarios. So maybe your fabric is designed to support a hybrid cloud. Maybe you're deploying these products and technologies in support of a VDI initiative or any of the other scenarios that are listed up there. Okay, so what we're trying to do is bring all of the things that are common to all of those scenarios, pull them out, put them into the fabric and fabric management architectures, and then anything that's unique to a VDI environment or a hybrid cloud or something like that, we have additional documentation related to that. Okay, so the stuff on the left is what we will soon be publishing onto TechNet for you all to be consumers of. The middle part are the services offerings that we as a services organization and our partners who are in certain partner programs can help you do some of these projects as you do Microsoft technology deployments. So the middle column there is our portfolio of services. And they basically follow a progression from doing basic infrastructure and management to consolidation and migration to automation, modernization, and then operating this environment. So what we've basically done is take the life cycle of a deployment or an engagement and said, okay, we're going to have targeted offerings for each of those different phases that customers might go through. So for instance, if you're already on the Microsoft platform, you've already deployed Server 2012 and Hyper-V and System Center, but you're looking at, okay, well, how do I migrate from my legacy environment into this environment? You know, we have an offering for that. If you've already done a migration and you have a large Microsoft infrastructure, and now you're looking to use some of the cool automation features in Orchestrator or Service Manager, we have an offering that's related to those scenarios to pick some of the most common operations that are cost or time prohibitive in your environment and automate those. So basically, as a services organization, this is our attempt to take a look at the overall data center space, try and develop these solutions so that we can accelerate the customer's time to value. Okay, so as I already mentioned, there's sort of two components to the PLA, fabric and then management. And then we're going to drill into each of those. Okay, so again, the PLA is for customers who want to fit into particular scale points. So the architectures that we are going to talk about today are generally for medium to large scale customers. Okay, so the definition of that would be maybe 8 to 12 Hyper-V hosts and a couple hundred VMs on the low end to hundreds of hosts, thousands of VMs on the high end. Okay, so we're targeting again sort of the medium to larger scale type of environments. The solution and the architecture can scale up or scale down. So those options are in there, and you'll see that when you see the documentation. It's geared towards both new deployments or upgrades from existing Microsoft platforms for the 2012 wave. And then it's for customers that are looking for reliability, stability, and supportability. So what I mean by that is we have a team of experts that have created this architecture. However, we've also worked directly with the product groups on these architectures. And what you'll see is these architectures manifest themselves in different programs that you've heard about at the conference, things like Fast Track, things like our partner programs, and so forth. So what we've really been able to do is drive some architecture consistency across most of the Microsoft programs related to this space. Okay. So a couple of the attributes that we tried to do in here is some of the ones on the bottom. I'm not going to drain those, in terms of description. But the whole point of it was rather than have individual teams at different customers or customers, on their own having to figure all of this stuff out, what we've done is sort of create this living architecture. Okay, so we update this as we learn new things. We update it as we do new products and new releases and service packs and so forth. Okay, so basically it prevents you from having to do all of that heavy lifting on your own because most customers are resource and time constrained. Okay. So you might ask, well, hey, Server 2012 is relatively new. Certainly System Center 2012 Service Pack 1 is very new. How do we have product line architectures for these things already? And the answer is because all of us that are involved in this program are part of the TAP programs. We work with the product groups. We do the rapid deployment programs. So basically, we're able to go out to customers, usually from the beta and RC timeframe in the product releases, and start learning the lessons of that product. Learn all the new features and functionality, do initial designs and deployments and so forth, gather some of the initial best practices, and build those into documentation. So what we try to do is target a timeframe where, very soon after a new version of the product releases, we'll have an update to these product line architectures that reflect those new product scenarios. Okay, so there's a continuous feedback loop there. Okay. So in terms of where is this intellectual property used, like I said, it's used in a bunch of different programs across Microsoft. So earlier in the week, Adam did a session with the product group on the Private Cloud Fast Track program, where we work with all the different hardware OEMs to certify this architecture on their hardware. Okay, so what that means is if you buy a fast track solution from Dell, from Cisco, from HP, and so forth, and it's a fast track SKU, you will be getting this reference architecture, and you will know if you deploy it that it's already been tested, validated, certified, and so forth to run on their particular hardware. Okay? For service providers and for enterprise, the same content manifests itself in the PLA documents that we'll talk about here. And then one of the prime benefits of doing this product line architecture for infrastructure is when it comes time to deploy workloads onto that infrastructure. Okay, so if we want to design an Exchange environment to run on top of Hyper-V and be managed by System Center, what would that look like? Or SharePoint, or Lync, or SQL, or any of the other Microsoft or third-party applications. So by having a standard architecture for infrastructure, we also have standard architectures for the products that you see up there. And what we're in the process of doing is making all of those architectures modular and deployable together. So if you as a customer come to Microsoft and say, hey, we want to get on Exchange 2013 and SharePoint and Lync, and we want to do this on top of Hyper-V in sort of an infrastructure as a service environment, we have product line architectures for all of those different modules. Combine those together so that you're getting a total deployment of a known good solution. Okay? So that's the overview of what it is, why we do this concept called product line architectures. For the sort of more technical part of the session, what we want to get into is the details of the fabric architecture and fabric management. Okay? So in terms of fabric architecture, what we've determined is that there's a lot of best practices ways of deploying Hyper-V. And then the primary differences in the different types of deployment models that we've seen in the last 6 months really relates to the customer's choice of storage architecture. Okay, so there's a number of different ways that you can do Hyper-V and clustering utilizing different types of storage. And they basically align to one of these 3 patterns. Okay, so we're going to drill into what each of those are. The first pattern is what we're calling a non-converged infrastructure pattern. So what that means is that the storage traffic and the network traffic will run over 2 different networks. Think of your traditional fiber channel SAN environment. Okay, you've got a LAN side of your servers, you've got a SAN attached side of your servers, and your storage traffic and your network traffic run on different infrastructures. Okay, by far, most customers today operate in this type of environment. So this is sort of the thing that we see most at customers today. So what that looks like is that on the left-hand side, you'll have your SAN storage. And then on the right-hand side, you'll have 1 or more Hyper-V clusters. Okay? Now, what you'll see is each of those Hyper-V servers has 2 or more NICs and 2 or more HBAs. And what you see is 2 different networks, the LAN side and the SAN side in this infrastructure. So this is pretty common. Most people are familiar with this. For 2008 R2, this was by far the most common sort of design pattern that was out there. So this is a well-proven architecture. As you can see in the pavilion, we've got tons of hardware partners that map to this particular scenario. Okay? In a little bit more detail, what that would look like in terms of Server 2012 is, there's a bunch of new features around NIC teaming, storage MPIO, and a few other things that are out there that enable a high availability scenario when we're doing Hyper-V clustering with SANs. Okay, so in the series of diagrams that I'm going to show in each scenario, the red represents physical hardware, and then the blue represents Windows or Hyper-V functionality. Okay, so in this particular case, what we're looking at is you can have, your teamed gigabit adapters, HBAs using MPIO, and so forth. So pretty traditional design pattern. You see the two different networks for SAN and storage. So this can be a very high performance infrastructure, but it tends to be one of the sort of the higher average cost infrastructures because you've got both SAN and network infrastructure to purchase, and you have multiple connections and all those ports and so forth. Okay, so robust, but not necessarily the lowest cost scenario. The next type of design pattern that we have in our reference architecture is more of a converged infrastructure pattern. So what this means is, again, it mostly relates back to storage. This is where both your storage traffic and your LAN traffic will utilize a common transport. Okay, typically Ethernet, or in some cases, InfiniBand or something like that. Okay, so in this scenario, this is where customers want to maybe start looking at architectures that reduce some of their hardware cost. Okay, so since you're running storage and SAN over the same infrastructure, that's a smaller number of infrastructure switches. It's a smaller port count, a smaller number of adapters that you may have to have in your physical servers and so forth. Okay, so a variety of different vendors, most of the OEMs provide solutions in this type of scenario. One example is the Cisco UCS solution, or anybody that's doing fiber channel over Ethernet, or iSCSI-based scenarios. Okay. So what that looks like is similar to the previous pattern. On the left-hand side, you have a SAN. This could be fiber channel or iSCSI. But what you'll notice at this point is there's no LAN side over on the right. Basically, both the storage network and the LAN traffic go over that LAN environment. Okay, and so instead of the server having to have NICs and HBAs, it basically has a CNA, or a converged network adapter, which lets you run both types of traffic there. Okay, so if you think about switches, port counts, number of wires, all these types of things, there is a pretty significant hardware cost, especially if you're a larger data center, by converging that type of traffic. There's other advantages there as well, is that you can do quality of service and balancing between different types of traffic and so forth. Okay, so there's a number of different benefits to a converged type of infrastructure. Okay. So again, what that looks like from a little bit more detailed point of view is, again, now you just have a pair of converged network adapters. And what you can see is some of the segmentation of storage traffic, LAN traffic, and so forth is happening in hardware. Okay, so if you think of Cisco, or if you think of HP with their Flex technology, there's basically this scenario where you can say, well, I want 20% of my bandwidth to be able to be allocated to LAN. I want 40% allocated to storage, and then a couple percent allocated to management or something like that to make sure you can always get to your servers. Okay, so in a converged network scenario, usually a fair amount of that network and storage level management is happening within the hardware itself. Okay, so that's something that the converged design has as a typical pattern. The one I wanted to spend a little bit more time on is the one that is net new to Microsoft in the 2012 wave. And we're calling this the continuous availability over SMB storage design pattern. Okay, so there's been a number of sessions at MMS that hopefully you guys have attended that talk about SMB storage, what the file services team did in Windows Server 2012, and so forth. So what we're going to drill into is a little bit about what that pattern would look like and how you might implement that in your environment. Okay. So within the pattern, there's 3 different variations, okay? And so the concept in this pattern is that rather than have to have your storage be on a SAN environment, you have options. You basically, your VMs, your SQL servers, or your file servers would be accessing their data over file shares presented by either a Windows file server cluster or a NAS device or something like that provided by a Microsoft hardware partner. Okay, so what that looks like in a variation A, so in this scenario, you've got 2 different clusters. Okay, so the left-hand side is what's called a scale-out file cluster in Server 2012. Okay, and so what this means is you're going to attach 2 or more Windows Server 2012 file servers to shared SAS storage. Okay, so what that means is you can go out and buy commodity disks, commodity disk trays, hook your servers up to that SAS storage, and then have that left-hand side function as your SAN environment. Okay, so what that means is I'll have 2 or more Windows file servers connected to that storage. We'll use storage spaces, which is new technology in Server 2012, to virtualize all of those disks. And then what we'll do is we'll present highly available file shares to the right-hand side, which is our workloads. So in this diagram, the right-hand side is Hyper-V clusters. It could also be SQL clusters, file clusters, or IIS web farm or something like that. So what you're seeing here is the Hyper-V clusters are actually connecting to the file server over the Ethernet network to access their storage. Okay, so what that means, if you go into Hyper-V Manager and you say, okay, where do you want to store your VHD file? You just type in / / file server name and share name, and now your storage is going to exist on that file server. Okay? A number of new technologies in Server 2012, the SMB3 protocol, some of the things mentioned up there, RDMA, SMB transparent failover, all the things that the product group has talked about this week in terms of new features in the storage stack. Those can be utilized by the Hyper-V servers to talk to those file servers at basically wire speed. Okay, so in one of the earlier sessions, I believe there's already been some demos showing 10, 15, 20 gigabits per second throughput from VMs over to these Server 2012 file servers. So just extreme performance there. Okay, that transport between the Hyper-V servers and the file clusters can be either Ethernet or InfiniBand. Okay, so you can pair together multiple 10 gig Ethernet adapters and get massive throughput from one side to the other. Same thing for InfiniBand. InfiniBand today runs at 56 gigabits per second wire speed. You can pair 2 or 4 of those together and get extreme throughput between both of these different cluster types. Okay, so the interesting part about this design pattern is commodity storage, commodity disk trays, Windows servers, all put together to have a very high performant, and scalable solution. And with this one, we believe we can really hit a very low cost point. Okay, so that's one of the things that's really we're enthused about in this type of design is, we can probably bring the cost per VM pretty far down, without having to sacrifice performance or features and so forth. Okay, so a little bit more detail of what that looks like. In a 2-node file cluster scenario, you have a left node and a right node there. The servers each have multiple SAS adapters connected to them. And then those SAS adapters are connecting to a SAS storage tray. Okay, so in this case, got one tray, bunch of disks in there, hooked up to our cluster, and that's what provides that shared storage. Okay. A little bit more complex scenario, if you really want to build a very high capacity file server cluster, basically what you could do is have multiple SAS trays. You could introduce a SAS switch layer, which really is just, they're relatively inexpensive switches that just let you plug a whole bunch of SAS connections from servers into a whole bunch of SAS connected disk trays. Okay? In my home lab at home, I have sort of a scaled down version of that, so it's still in sort of that commodity price range, but it lets you scale up to hundreds of disks, 2, 4, 8 node file clusters and things like that. I think in the demo that was getting 15 or 20 gigabits throughput, I think it was a 2-socket server and then 1 or 2 disk trays like that, a couple of SAS HBAs in each server, and then it had that sort of very high throughput level. So this is just a scenario that would look at a little bit more enterprise scale than the previous example. Okay, one more scenario here. This one's a little bit more obscure, but it's something that is supported in Server 2012, which is there's new type of RAID adapters out there that are called clustered RAID or clustered PCI RAID controllers. And basically what these adapters let you do is have relatively dumb storage, but have some intelligence in the RAID adapters to be able to share storage across multiple physical servers. Okay, so I just put it in there for reference. If you search on that clustered RAID term, you'll go to a couple of TechNet articles. There's a few vendors providing those solutions today, but it's not quite as mainstream as the other ones that I've showed. Okay. So there's a couple of considerations and things like that here for variation A. We put that in there for reference. These are basically the support statements that say these are the type of SAS hardware you need to have in order to support a clustered scenario and so forth. All of that content and then all of the details of how to design this infrastructure is what we've captured in those PLA documents. So once they get released on TechNet, you'll be able to see all kinds of details in terms of design recommendations. Okay, so now I'll turn it over to Adam, who's going to talk about the fabric management architecture.
Thanks, Steve. And thank you all for staying late on a Wednesday. So we saw a lot about the fabric there, a lot of cool innovation that we can do. The primary scenario we're targeting on the management side is really formulating that holistic private cloud solution. So I know we're at a System Center focused event, and there's a lot of management capabilities in System Center that are not about cloud, but that's what this architecture focuses on, is really about taking that fabric that Dave just described and formulating a private cloud system that provides things, for example, our three main pillars. So before these pillars, there's really kind of three main components we think of that constitutes a cloud architecture. There's the fabric, there's the management, and then there's operations. So this is really the three main pillars just for the management tier. So service delivery, this is things like financial management, being able to do things like chargeback or showback, being able to provide self-service to your end users, being able to do the lifecycle management of the services that you're providing those users. Process automation and orchestration, that of course is the components that basically allow that service delivery layer to talk to the fabric in a coordinated way. So to do very complex things like patch an entire data center fabric without having to do any sort of manual processes in there. And then fabric management is what allows the workloads riding on top of the fabric and the fabric itself to be able to do pretty complicated things without having to do them, without having to have manual intervention in there. Things like dynamic optimization, so being able to balance workloads across your hosts in an even way. Things like patch management, maintenance of the systems, service templates that have maybe affinity. So if you have clustered guests, they understand where they should run and where they should not run, are some examples. So I won't belabor this slide too much, but I just wanted to, this is a product group slide that they use to describe the layers of this, of a private cloud, the different personas from the consumption side to the administrative side, and all of the functions and capabilities in between and where sort of the products fit there. Now what I'm going to do is dig into how do we actually architect the management tier to fulfill this vision, if you will. So let me fly through that. So the stuff that Dave was just describing is really contained in this box at the bottom here. This is everything from facilities to storage, network, and compute, including the virtualization layer. To be honest, in a private cloud configuration, the virtualization hypervisor of choice isn't really very relevant. It's just an endpoint. It could be Hyper-V, it could be vSphere, it could be Xen. What is really relevant is the tiers up above. So starting at the automation layer, as I'm sure you all know, System Center products have PowerShell now as kind of their foundation. So everything that is exposed in the GUI and more is exposed via PowerShell and other automation techniques underneath the hood. That's what allows that management tier to really talk to the underlying fabric in an automated way. So the management tier, which I'll dig into in more detail, are the things that control the fabric itself and do things like automation and orchestration. Orchestration tier up above, all right, is what talks to the management layer. So Orchestrator talks to Virtual Machine Manager and tells it what things to do. Virtual Machine Manager is what talks directly to the fabric. Service management can be quite a large tier or a very short, kind of small and compact depending on the needs of your environment. So you can do anything in there from change control and governance to incident and problem management. Or maybe you're just using that for the CMDB, which understands the relationships between these tiers. And then finally, the self-service tier. We have a couple of choices there, App Controller and the Service Manager portal. But that's really the layer that it gets presented up to either IT administrators or consumers of the IT services themselves if you want to build a service catalog and offer those out. So how do we actually deploy this stack? Now, before I get into this, I want to say that there are a number of ways to deploy System Center. And we're not saying this is the only way. We're just saying that in our reference architecture, for a certain scale points that Dave was talking about, this is how we would deploy System Center per the product group guidance for a holistic private cloud solution that's highly available and scalable. So you can certainly deploy and scale out each of these tiers larger or actually much smaller as well. So first of all, we have a 2-node Hyper-V cluster just for the management tier. We do that for scalability and performance so that our System Center components and SQL don't impact the running workloads on the fabric. And we use the best available high availability technique for that component. So for instance, Operations Manager has built-in high availability. We don't need to leverage host clustering. These components we do. So we have Service Manager management servers here. We have a Service Manager data warehouse. We have a Service Manager self-service portal, which also runs SharePoint Foundation as its web tier. We have App Controller, and then Operations Manager reporting server, and then an optional deployment server. This would do things like WDS and Pixie and WSUS to provide functions like patching of the fabric or bare metal deployment of the Hyper-V clusters. Moving up, these components have native high availability built in. So we have 2 Operations Manager servers and 2 Orchestrator Action servers. And then finally at the top, these leverage guest clustering, so Windows failover clustering from within inside the guest. And we have 2 Virtual Machine Manager servers and our SQL cluster. We don't require 4 SQL cluster nodes. You could run all this stuff on one SQL node. We just have different scale points. So we generally start with 2 and then scale out depending on the size of the environment. So now I'm going to dig into, basically I'm going to give you I'm going to tease you with some of the information that's available in the reference architecture for the management tier. This will be on TechNet soon, so if any of this you have questions about, I'm glad to talk to you afterwards, but also be sure to go download that and check it out because we've tried to put a lot of knowledge in here and a lot of guidance in here. Scalability is always a question. How large can I scale? How much disk capacity do I need for these components? How large of an environment can I manage with this architecture? So one thing we've learned as System Center has evolved as a product is that, first of all, each of the components were built with sort of different scalability guidance. And now we're trying to rationalize that guidance across the whole stack. And so that is taking some time to sort of flesh that out. So this is one of the first attempts to really do that, to say if you're going to use all of the System Center components to do a private cloud, what is the scalability across all of the different components? So in Virtual Machine Manager, we have native ability to scale up to 800 hosts and 25,000 virtual machines per Virtual Machine Manager instance. We can do more than that, but you need additional Virtual Machine Manager deployments.
Yeah, that number was increased to 1,000 a couple of weeks ago. So basically the number is 1,000 hosts or 25,000 virtual machines.
Okay. If you add these additional new things coming along, the Service Provider Foundation, there's additional scalability considerations there. But that's sort of the baseline.
Yeah, that one is important because if anybody is from sort of a hosting provider who's looking at doing Service Provider Foundation, there is some differences in terms of the guidance around that particular scenario. For enterprise customers where you're doing sort of a deployment of VMM for your whole enterprise, the top number applies. For Service Provider Foundation, the lower number provides. However, in the SPF scenario, you can have multiple stamps of VMM servers. So it doesn't mean it's limited to just that number. It just means you'd have additional VMM virtual machines in that topology.
Yeah, if you're not familiar with SPF, you can go watch a session on it online or maybe this week. But it sort of is a tier that sits on top of System Center and can talk to multiple VMM instances. So that's a different architecture. App Controller is really proportional to what VMM supports. And then we have up to 250 virtual machines per user role that are exposed in the portal itself. Something to be aware of. Operations Manager is really about how many agents it's going to be talking to. So up to 3,000 agents. We do require an Operations Manager agent on your Hyper-V host. So we're good to go there. But if you want to deploy agents inside the guest as well, that's a scale point to consider. You can certainly scale much larger than that. You just need additional management servers. Orchestrator, this is sort of a standard baseline of 50 simultaneous runbooks per runbook server. Again, you can scale higher than that if needed, but there's just additional architecture design needed there. And then Service Manager, the deployment model that I just showed you supports about up to 20,000 computer objects. We can, again, go higher than that. We just need more scalability on the Service Manager tier. So moving into some key considerations. Service accounts, groups, and permissions. These are really the Active Directory requirements. Again, I really want you to go download the document if you're going to deploy this configuration, because we've articulated out exactly what service accounts you need, what permissions they need on what servers, et cetera. But the really important thing to do is define them in advance, basically before you get to the installation wizard. Okay? Have a spreadsheet that documents out what your service accounts are going to be, where they're going to have permissions on what components, how you're going to manage the passwords, and what groups they're going to be members of. So we have guidance there. It's not prescriptive. It's flexible. You can consolidate some of these service accounts down to less, a lot less. But please don't consolidate it down to just using, the domain admin account. So
yeah, we still see that a fair amount. If people wait until that installation wizard comes up, and then it's like, okay, we'll just use the same account for everything. So not good.
And then you'll notice if you download this guidance, you'll notice that we have kind of what seems like a lot of service accounts, and that's because we're trying to execute this principle of least privilege across the stack. We have worked, in the previous session, Carmen Summers was up here. She's kind of one of the deployment and installation leads on the System Center team. We've worked with her very closely on this, and they've seen what it takes to do an enterprise production deployment, and they've seen, oh my gosh, that's a lot of accounts. And they're working very hard to get that number lower and lower each release. So there's a lot of good synergy there.
Yeah, some of the derivation of that before we go on to the next section. So again, the architecture is for Server 2012 and System Center is relatively new. But one thing that I didn't mention up front is that we've basically been maintaining this sort of body of knowledge of architecture for about 7 years, all the way back to the virtual server 2005 days and things like that. So we've had sort of virtualization and management architecture that we've evolved over time. And then what's really been a pretty big success point is what Adam just mentioned, which is we're able to, as the services side of Microsoft, sort of take that architecture back to the product groups and say, look, when you combine all of the guidance, all of the TechNet articles, all of the recommendations that people make across security and all of these different areas, this is the end result, sort of best practices architecture. Mm-hmm. Sometimes that results in an architecture that's fairly complex with the service accounts and some of the stuff that we'll see here with SQL. However, it is following those best practices, and then now what we're doing is doing that feedback loop with the product groups so that in cases where it might not need to be that complex, if they make some changes, we're communicating those things back. So we're taking sort of that customer experience and then closing that loop with the product group.
Exactly, and really, Microsoft Consulting Services is the voice of you all, of the customer, when we do deployments and we experience this pain back to the product groups, and like that feedback loop Dave was talking about does eventually get back into the product planning cycles. So the next key decision point as you deploy is the SQL Server architecture. I'm sure you're familiar with this from your own deployments, but when you're deploying all of this in a private cloud solution, what is your SQL topology going to look like? Do you have an existing SQL farm that you want to leverage? Do you want to use one SQL Server local to each component? Or what we recommend is a multi-instance failover cluster. So as part of our deployment guidance, we would start with a two-node SQL guest cluster and house multiple SQL instances on that cluster. And so we have the failover clustering for the on-premises high availability and scalability, and then we can also leverage SQL Always On for remote disaster recovery of the SQL environment. Again, there are many deployment options when it comes to SQL. You can, of course, use an existing SQL environment. You can, of course, deploy a SQL server per local component of System Center. But this is sort of the best practice way that we recommend.
And one reason for this, you'll see the high availability theme is sort of weaved throughout all of these architectures. So especially when we're looking at infrastructure as a service, if the customer is going to be having sort of a self-service portal where developers can go request VMs, or if they're going to use this common system center infrastructure to manage their entire environment, the fabric and the fabric management infrastructure become mission critical services, just like any sort of line of business application would be. So some of the reason for a little bit of complexity in the architecture is because we're providing high availability at every layer. So in the fabric part I talked about, complete redundancy. In the system center part that we're talking about here, all the way from SQL up to the individual products, high availability as well.
It really does become important. If you come by our one of our data center services booths this week, we can show you some data center automation runbooks that we've constructed in our offerings. If some of this environment is really poorly performing or not available, those are going to fail, and your data center maintenance routines or whatever it is you're doing in the environment is also not going to work. So it really does become a critical component of the cloud, especially if you're providing services to end users. And maybe this is a new experience for them, and you really want that first new experience with a new architecture to be a positive one. So you can see these are the SQL instances, databases, and LUNs. The instances are the big vertical boxes. The databases are the blue ones inside there, and then the LUNs finally are down below. Again, this is the way to do it in the most scalable, highly available manner. So we have a shared instance over here, starting on the left, that houses the SharePoint Foundation databases, the Orchestrator and App Controller database. Those can all be co-located. Then we have a Service Manager instance. We have a Service Manager Data Warehouse instance, an Analysis Services instance for Service Manager. Analysis Services, in case you're not aware, is for doing some of the predictive reportings that we have with the VMM and Ops Manager integration. Things to tell you like, when am I going to run out of storage capacity? How fast is my virtual machine consumption growing in my environment? And then finally, Virtual Machine Manager, SCOM, and the SCOM Data Warehouse.
So the reason there's sort of these different instances and so forth is, if you think about what Adam described, is we've got a set of 2 physical servers that all of SQL and System Center are running on in VMs. Then we have this guest cluster of 2 or more SQL Server VMs. Because each of the individual System Center components has its own database instance, what that lets us do is scale those instances and those virtual machines sort of independently. So what this lets us do is we can scale this design down to where there's just 2 SQL Server VMs clustered running all of this stuff. Or in a larger scenario, what we can do is we can say, well, we're going to have a VM in the SQL cluster for every instance. So you could scale it out and say, I'm going to have 6 VMs in this guest cluster, and then scale up those VMs and so forth, and spread the instances between them. So by having a fully virtualized design and then having that multi-instance scenario, it really lets us flex that whole System Center infrastructure from relatively small scale, or able to support these larger scenarios.
Right, flexible scalability is the key there. There is some planning guidance in the documentation as well. If you happen to know some information about your environment, you can plug it in. So how many Active Directory objects, how many hosts and VMs am I planning to use? And that'll help you do some sizing on the SQL database size. So moving on to some other components, Virtual Machine Manager. We talked about why it's important to make it highly available. I won't belabor that. One thing to note is that the built-in VMM HA uses guest clustering. It doesn't provide additional scalability, so you do need to still size those VMs appropriately. It's not an active-active type of topology. So for complete high availability of VMM, though, we also need SQL high availability, and we also need library high availability. So when you do a highly available VMM deployment, you cannot host the library on that same cluster. There's a couple ways you can handle that library share for your library objects. You can have an existing file share somewhere in your environment, whether it be SAN-based, on an SMB3 scale-out file server cluster like Dave was talking about. Or you can optionally have that library on the SQL cluster that I just showed you. You could certainly do that as well. VMM setup is integrated with there. The console connection should use the cluster name of the service instead of an individual node. So that allows the console to connect regardless of which node is online. Some points around Service Manager. And once I get through these, I'll show you the sort of the overall integration for these components. So maybe it'll kind of crystallize in your mind how these things all fit together as a whole. But the connectors, if you're not familiar in Service Manager, basically allows Service Manager to import items from your environment, from Active Directory, from Operations Manager, from Virtual Machine Manager into the CMDB. In order to install those connectors, you have to consider things like ports and service accounts. We generally use a dedicated service account for the connectors. So we have just a connector-specific service account that just has the privileges that that connector needs to do object imports. That way we're not using the same kind of highly privileged service account as the System Center component to do just the connector traffic. One thing to note about Service Manager is it is a service management tool, and the Technic guidance is really focused around using it that way. However, we are using it just for a private cloud, part of a private cloud architecture. And the guidance isn't really written for that, so that's where we fill in the gaps with some of our management guidance here. We do use, like I mentioned, SharePoint Foundation for the portal portion of Service Manager. It's a lightweight SharePoint. It's on the same box as the portal itself. We do need certificates. It's not a hard requirement, but we highly recommend using SSL for your enterprise authentication. And there are version constraints around SharePoint for doing that portal. Very recently, SharePoint released a service pack. I won't get into the details here, but just to say that the guidance will tell you exactly what you need, and that there is a new service pack for SharePoint Foundation that we leverage. The Active Directory connector, if you've not done this before, basically what this is going to do is it's going to import all of your Active Directory objects into Service Manager as configuration items so that you can do things like provide access to the service catalog and the clouds that you want your end users to be able to provision into. However, it's going to import everything in your entire AD unless you are targeted about this connector. So there's some ideas about how to do that, but it's just to say that if you just kind of fly through the wizard and set up this connector, you're going to all of a sudden have a very large Service Manager environment depending on the size of your Active Directory. And it kind of takes a while to clean that up after the fact. So something to be aware of. App Controller is a very easy installation. It basically leverages the constructs of Virtual Machine Manager. So App Controller talks directly to Virtual Machine Manager. It is an additional self-service portal option that works well in conjunction with the Service Manager portal. It's just something to be aware of that the users that are defined in VMM, that is what's going to define the access via App Controller. So you've got two different places to manage identities if you're going to use both of the portals together in conjunction with each other. And again, if you come see us in the expo hall later, we can talk to you about some of the design considerations and usage considerations in that scenario. Orchestrator, so the integration packs for Orchestrator are what enables the automation of the fabric and the cloud service delivery that I've been talking about. So we do use all of the System Center integration packs. There are, of course, additional integration packs as well. If you want to burst out to Azure for some capacity, there's an Azure integration pack. You could certainly build your runbooks to include that. So when we use the System Center Orchestrator connector in Service Manager, we need to use this web service URL. It gives you a hint on where to find that. And that's what allows the connector to talk to that. I talked about runbook scalability. And finally, as I'll depict later, these connectors populate the CMDB with configuration items.
Yeah, so this area, Orchestrator in particular, is one of the, when you start thinking about that, then having sort of this reference architecture starts to make sense. So one of the things that we're showing in the expo hall is something that we're calling our data center automation framework. And so in addition and alongside of this guidance, we also have best practices for how to design Orchestrator runbooks in a modular way and in a sort of a transportable way. One of the key enablers to that is having sort of this known architecture in place. You know VMM is there, you know Service Manager is there, you know the different components of System Center are there. That's what is letting us create these runbooks, and we can test them against this reference architecture and then know that those runbooks will work in anywhere else where this architecture has been deployed. So it's just one of those areas where, at the top we said this is extensible. That's what we mean by that. Common architecture, you can make some of these runbooks and then know it'll run in those environments.
Exactly. I mean, if you're trying to build a data center automation runbook library, and you can't reliably say that a connector is going to be in place that will have imported these objects that you're dependent on, you're kind of stuck. So in order to mature your operations, you've got to have sort of a common baseline starting point. So one of the things I use to describe to customers what this all looks like after you've talked about capabilities and features and architectures and so on and so forth is, what does the environment look like when you're done actually installing it and integrating it? Especially because many customers have existing service desk tools. They might have existing reporting engines. They might have an existing Active Directory environment. They want to know what it looks like from an integration perspective. So the first thing to note, as I don't think I need to sell this concept to you, but System Center 2012 SP1 really has a lot of integration points with third-party systems. It tries to be very inclusive with heterogeneous and interoperability are big key investment areas. So although we do have, for instance, our own Service Manager system in CMDB, we can certainly integrate with another one as well there. We can send incidents over to another ticketing system. We can send configuration management database items over to another CMDB, so on and so forth. But if you follow the deployment guidance that is included with this guidance set, and you get to just the installation, this is what you sort of end up with from a logical perspective. So you have, at the top tier there, you have App Controller Self-Service Portal and the Service Manager Self-Service Portal, and in the middle, the Service Manager server itself with its configuration management database. Then down below here, we have Orchestrator, Virtual Machine Manager, and Operations Manager. Active Directory, of course, we need. And then we have our data warehousing for Service Manager and Operations Manager. We have the Hyper-V fabric that Dave talked about constructing, and then maybe public cloud providers up above. Of course, we prefer Azure. Then you have a couple native integration points. These are abilities to connect these systems together with just a simple username and password. In the case of Azure, you need to exchange some certificates, but generally very simple. The next level of integration is that we shove reporting data over to our data warehouses. That allows you to do some pretty deep and rich reporting, both inbox stuff and also build your own if you need to. The next integration point is the integration between Virtual Machine Manager, Operations Manager, and Hyper-V. This is sort of key. This allows us to do some pretty cool, sophisticated stuff. So by integrating VMM and OM, for instance, anything that VMM manages automatically is discovered and monitored by Operations Manager. So any Hyper-V systems, any vSphere systems that Virtual Machine Manager is talking to is automatically reflected, and you get health data, you get performance data over in Operations Manager. And then you have, of course, the reporting data out to the data warehouse for further reporting. These are the configuration item connectors that I've been talking about. These are the 4 that we kind of require that are installed for this architecture. There are more available. So for instance, for Operations Manager, you can have an alerts connector that basically says anything that pops up a health alert in Operations Manager, I'm going to automatically open an incident in Service Manager. When the incident's resolved, it'll close the alert in Ops Manager. So there's more available there, but these are the 4 that we really need to make this thing work. So we need Active Directory configuration items, we need VMM items, we need those Orchestrator runbooks, and we need Ops Manager data. And then last but not least, we have integration packs. These are, of course, the things that we configure in Orchestrator that allows it to natively talk to these products via those pre-configured activities. Those Orchestrator activities are a godsend for someone like me who is not a developer, and I don't know how to write 1,000 lines of PowerShell to talk to Virtual Machine Manager, for instance. Now I don't need to. I just have an activity that says provision VM, start or stop the VM, etc., and I can build the logic in there in a graphical way. Of course, there's a lot more integration packs too. If I had for instance, a service request that was about provisioning a service, maybe it's a SQL cluster, and depending on the business unit that's requesting that, I might want it on premises, I might want it in the cloud. I have an integration pack for Azure, and I can have the logic built in that says, if this department is requesting this service, it's going to go here versus there. So there's a lot you can do with this architecture.
All right. So basically, to summarize a little bit, Adam and I got to be sort of the point people and presenters in this session, but everything that you saw here, and especially the documentation that you'll see published shortly, was created by a team of people, some of whom are in this room, some of whom couldn't make it. What we showed you really was some of the overall design diagrams and then some of the design rationale and so forth. Behind the scenes, and what you'll see is the product line architecture for the Hyper-V Fabric. That's about 150 pages of architecture guidance. The fabric management document is about the same type of size as well. So we're talking about a couple hundred pages of design guidance. Here's features. Here's how they get used together. Here's the design recommendations and so forth. So that's sort of the scale, at least from an intellectual property perspective, of what you'll see up there. In terms of a call to action, one way you can get access to this thinking we already mentioned, which is through the Fast Track program. So what happens is the vendors take this architecture and then they actually can extend it even further. Okay, so in my slides where I showed, hey, there's these red boxes, which is some things that are happening in hardware, what that means is each of these vendors might do it differently, and then they document that their technologies and where it fits into our architecture. So for instance, in the Cisco case, with UCS, and they have their own NIC teaming that they do in their converged network adapters. So in that section of our reference architecture, they'll extend that section and they'll talk about their solution. Same thing with HP with Flex and Dell with their stuff and so forth. Okay, so yeah. Go ahead.
Also here this week, just so you know, if you're interested, Cisco, NetApp, HP, and EMC all have their Fast Track gear here at the conference. You can go talk to the guys who developed that jointly with us and check it out.
Yeah, absolutely. So from the hardware side, there's a bunch of stuff here from those vendors that you can see. Also in the services pavilion, which is sort of the green section of the Expo Center, we have the architectures that we talked about here running. We have the data center automation, all the orchestrator stuff. We also show what you can do once you have this architecture in place in terms of automated deployment of things like SharePoint. So at one of our booths, what we're showing is VMM service templates and orchestrator runbooks running on top of this infrastructure that is automatically able to deploy a whole SharePoint farm. Okay, so again, utilizing sort of that common architecture foundation. So in terms of next steps, most customers are going to break down into a couple of these categories, at least those that are interested in this approach. First is the do-it-yourself. Okay, so this may be the case where you're either a relatively small customer or you have a large IT staff that's well trained on these technologies. So for a do-it-yourself scenario, that's why we're publishing some of the guidance that we talked about here. So that'll get published on TechNet. So again, we were hoping to have sort of the link ready for to be able to give to you right now. It's probably going to be a couple weeks from now, but where we'll announce it is on the TechNet private cloud blog. So if you go to blog.technet.com/private cloud, that'll be one area where we make the announcement. Plus, if you download these decks on the first page, Adam and I have our Twitter handles on there. We'll obviously post the links as soon as that's available as well. So for the do-it-yourself scenario, you'll get access to these documents. There's also some of this virtual training that's out there for free as well. For medium and large size customers that need assistance with this, that's where Microsoft Services comes in. So all that stuff I talked about at the top, the different offerings, the different engagement models and so forth, those are some things that we can assist with. They range in time from a couple of weeks to a couple months type of engagement, depending on the scope and size of what the customer wants to do. We also have workshops, proofs of concepts, things like that. So if you're still in sort of an evaluation phase, we can do a 1 or 2 day workshop with you. If you want to do a proof of concept in your environment, we have options for that. And then obviously full engagement. And then obviously the other channel for scale is through our partner programs. So Adam and I delivered a session similar to this to about 50 partners who are here at MMS yesterday. And we have partner programs where Microsoft certified partners get access to all of these materials and more, and they're building practices to help them enable customers to do these types of deployments. So there's a number of different ways that you can get access to the materials, a number of different ways you can get assistance in your environment if you need help with deploying these technologies. So we ended pretty much on time. We wanted to leave 10 or 15 minutes left in case folks had questions. Before we get into the questions, we definitely want to get your feedback on the session. Our organization is only presented here a couple of times. If you want more sessions like this where we get into sort of real-world architecture and implementation details, definitely put that in your evaluations. It helps us sort of get some of those sessions there in the future. So what we'll do is we'll sort of wrap the official part. It is being recorded, so if anybody has questions, if you could come to the mics, or if you're far away, we could repeat them, and we'll get those for the recordings. But Adam and I will stay around and answer any questions that you guys might have. So thank you.
Yeah, thanks very much for your time.
Hi.
I had one question regarding the reference architecture that you put. Where do you mention the use cases for that architecture? Like, is it for provisioning VMs or?
Mm-hmm. Yeah, they are in the documentation, absolutely. Very well spelled out, I think.
So do you go across all the scenarios we usually see, or is it a subset?
Yeah, so basically, for the most part, we targeted infrastructure as a service. So what we mean by that is cloud attributes. So we talk about user self-service, resource pooling, elasticity, and chargeback, and so forth. So that covers the full life cycle of virtual machine provisioning, patching, live migration, and so forth. The other thing that we showed at the top also is that we are taking the pure infrastructure as a service scenario and then extending that to support VDI deployments or hybrid cloud or things like that. Is there a particular scenario that you were interested in?
No, I was just wondering from the diagram that you put.
Yeah.
That's
The Fabric architecture guide is kind of like a foundational building block. The management goes on top of that and does define some use cases and scenarios. But then, like Dave was saying, we also have these offshoots of that for VDI, for hybrid cloud, et cetera, et cetera. So there's sort of the core architecture that enables certain scenarios, and then there are modules that we plug into that to do more sophisticated things. That's kind of how we build that out.
Thank you.
Thanks.
Any other questions? All right, thanks.